you very much, Mitch. I really appreciate it. And let me get this going, play, and let's see. Okay, great. Alrighty. Just to get the windows set up here, good. Hi, thank you very much. I really appreciate the opportunity to present here at Nodes. And I'm talking about using entity resolution and knowledge graphs together. Now, there's the slides that I have, there's a lot of links. I like to give direct links to primary sources or code repos, tutorials, videos, etc. So if you want to grab my slides, you can use this QR code or the URL that's right there. All of it's up online. And there's actually more slides that I'll be able to go through today. So this is just kind of my standard pack. I'm at a company called Sensing, and I'm principal DevRel engineer. I'm working in the knowledge graph practice area. And so just to give a flavor of a lot of what we do, about 60% of our customers are working in air-gapped environments. So these are highly secure environments, SCIFs, you might have heard them called. And so there's a lot of work on what I would characterize as investigative graphs. And I'll show that to show a flavor for a lot of this kind of work. So in popular media, there's been some great representations. If you haven't seen it, there's a film on Netflix called The Laundromat with Meryl Streep, Gary Oldman, Antonio Banderas, and others. And it's really funny, although it is a really serious topic. It's a great set of vignettes to describe a lot of what's happening across the world with flows of dark money, offshore firms, a lot of different forms of crime. Some of it is more financial crime, and some of it is legit, like, this is organized crime, or there's human trafficking, or there's weapons, illegal weapons trade, et cetera, et cetera. A lot of this has been exposed through work like the Panama Papers, the Bahama Papers, Luxembourg leaks, et cetera, from ICIJ. There's a great book about it called Moneyland from Oliver Bullough. But definitely check out some of this media to give more background. And I'm going to focus on just one case, and this was called the Azerbaijani laundromat. It was money laundering that was being done out of the Azerbaijani government, but also a lot of the wealthy elites in the country. Along with that, there were some arms exports from Russia, and there was also a lot of bribes. The laundered money was used to bribe politicians in European Union. And we know that at least $3 billion went through this scam called the Azerbaijani laundromat. There may have been more. It's just this is how much was eventually caught. This is being run through shell companies. They were nominally registered in the UK. There were 4 of them. And eventually somebody at Danske Bank, there was a whistleblower who leaked 17,000 transactions and showed a lot of the money transfers that were involved. And so people were able to piece together graphs to describe what had happened. And it really illustrates this thing where in financial crime, it's difficult to understand what's happening because, typically a lot of the dark money that's moving hands between offshore companies, they'll piecemeal it. They'll cut it up into little chunks, and they'll make one transfer, then another transfer, another transfer. But you can try to understand it from the perspective of like a burst in originators or burst in beneficiaries and try to aggregate. But at the end of the day, unless you have a graph to connect all these transactions through these multiple parties, because the crimes are being done using a network to obscure them, unless you can use a graph, it's going to be really hard to tell what was going on. And so knowledge graphs are extremely important for investigating fin crime. And there's a lot of issues. The big takeaway, though, is there's just huge amounts of data. It is connected data. It really begs using graphs. However, traditionally, most of this is being reviewed manually. And so when you have 17,000 transactions that have to be reviewed manually, it gets really complex. One of the taglines is that for this kind of thing, the money crosses the borders, but the laws don't. So just trying to track what has happened for offshore companies is just mind-numbingly difficult. But, at the end of the day, a lot of the problem is because there's a lack of computing tools. And this is where knowledge graphs, graph analytics, and downstream AI applications become really, really valuable. And also, I should mention that for this specific case, Azerbaijani laundromat, even though there's been like movies made about it, this stuff happened like over a decade ago. So far, nobody yet has gone to jail. And some of the officials who were bribed tens of millions of euros, they're bragging about how much they got away with it. So, this is a pretty big problem. And this is just one case. Now, to bring this into knowledge graphs, there's a really great presentation here by some of my colleagues, but I will mention Friedrich Lindenberg from Open Sanctions. And he, in this talk, is presenting about a data model for working with investigative graphs. And the idea is you really have three classes of data. You have risk, link, and event data. Risk data, I'll mention first, is like sanctions list, watch lists. Here are a bunch of oligarchs who are doing something suspect. Here are companies that have been involved in money laundering before. We're going to watch them closely. Here are people who are politically exposed persons. They're very likely to be people taking bribes. And there are watch lists. Over on the right-hand side, though, the event data, that might be money transfers, it might be shipping manifests, it might be some kind of logs or reporting. Oftentimes that's very confidential data. It's hard to obtain examples in open data. In this case, we actually do because there was a whistleblower who leaked the banking records. So we actually know about the payments data. The data in the middle, though, is really the connective tissue. This is the link data that connects the risk and event data. And it's what really builds out the graph. And it's so important. And this is where entity resolution comes in. So in this particular case, Azerbaijan laundromat, there's Open Sanctions is one data provider. They have almost 250 different data sources and really amazing information there. For the link data, there's open ownership, which talks about disclosing, who are the people really behind each company, and a lot of that information is being gathered globally through something called Ultimate Beneficial Owner. And there are others. There's GLEIF, there's ICIJ, was something I mentioned before, but there are various sources that are open for being able to do that kind of link data. The event data, like I say, it's usually confidential. In this case with Azerbaijani laundromat, there were leaks of the banking records, and those went to an organization called OCCRP, and they accept leak data either from banks or from law firms or whatever. ICIJ also accepts leak data. The Panama Papers, of course, is very famous because somebody leaked a whole bunch of documents from a law firm. So we've got three classes of open data we could build graphs out of. And we'll show a bit about that in a second here. I want to talk a bit, though, just to kind of frame this in terms of what the contemporary tooling is. And of course, GraphRAG has been hugely popular ever since September 2023. There are some great libraries for this, of course. Neo4j has the LLM Graph Builder. There's LlamaIndex is popular, LangChain, Haystack, Microsoft GraphRAG, etc. And there's just some really fantastic work out there for this. I would recommend also, I really like what Whitehall AI is doing. They've got Knowledge Graph Studio. It builds on top of, this is a layer above Graph Database, but it's for understanding sort of RAG native knowledge graphs, understanding the domains, building out agents. A lot of really interesting work there looking at domain-specific agents. Another one that I really like is called Ask News. This is from a company called emergentmethods.ai. They have a product where they're fine-tuning Microsoft's Phi3 Mini LLM and also doing fine-tuning on GLEIF to be able to essentially scan worldwide across many news sources and pick up connected data, knowledge graph data that would be on a particular topic, and where you have characterizations of like, what kind of bias is coming from this news source, how sensational is this particular article, etc. So a lot of really interesting applications of generative AI there. Here's an example of something from Ask News where they were looking at Ukraine, Russia, North Korea, and a lot of current reports coming across worldwide, understanding how these are interlinked based on the topics. And another one I'll point to that I really like is called the Sentry. They're doing a lot of proactive work across the world, but they do have some data projects, and one of them is a interactive network analysis of the Azerbaijani laundromat. And so it's great because you can visualize and see where the beneficial owners were, as is shown down here. Basically, what were the mechanisms for laundering the money, making all this illegal influence. And I'm mentioning all this because when you look at the public libraries that are, open source libraries that are popular, one of the things that you really tend to see is, and you talk with the developers who are doing this, a lot of times what they'll say is, hey, just throw the data into an LLM. LLM will generate the graph components, and then downstream from that, you've got a knowledge graph that you can use in GraphRAG. And so that's been a real prevalent idea. And I want to deconstruct that a bit because in some types of verticals, that doesn't work so well. When you're doing investigative graphs, yeah.
Paco, I'm sorry to interrupt. I just wanted to check. Should you be on a different slide right now? Your slides haven't advanced, and I just wanted to double check in case you think you're advancing them. They're not advancing.
You're kidding.
No, sadly, not kidding.
Crap. Okay. Do I need to start this over then? What do, damn, I was in presentation mode. Okay, where did it stop or where did it start?
I don't think it ever advanced.
Okay, let me try to advance now. Can you see anything now?
Yes, now it's moving.
Crap. Okay. Well, thank you for catching that.
Take a deep breath. Take a deep breath. It's okay.
Yeah, no, sure, that's fine. Okay, so you know what, everybody, go get my slides. They're online. You can use this QR code or you can use this URL, and we'll be publishing them online as well afterwards. I'll mention them on LinkedIn and in the chat and whatnot. Investigative graphs, a lot of popular media. Azerbaijani laundromat is a case study that I'm looking at in particular. $3 billion went through weapons, bribes, etc. It's really hard, but there are ways of using knowledge graph and using graph algorithms, using graph analytics to really connect the dots and find out where the fin crime is happening. And this is a data model that I'm presenting. Risk data, link data, event data comes from Friedrich Lindenberg at Open Sanctions. Okay, so now we're up to speed. GraphRAG libraries, I'll give a shout out to YHow, also Ask News, and also the Sentry. Some really good examples of doing work in this space. And I think we're up to speed now. Okay, thank you. I am going to talk about unbundling the knowledge graph construction because when you work in regulated environments, you're subject to audits, evidence handling, explaining why decisions are being made, regulatory compliance, etc. Frankly, in the investigation side, you're probably going to go in front of some judge. And if you go in front of a judge and say, well, we just threw the data at an LLM and the LLM decided how to connect the evidence together, that's probably not going to go over well in front of a judge. So in these kinds of environments, people want to be working more with curated graphs or really understanding the process more of how they're addressing data quality concerns, how they're blending their structured and unstructured data, how they're providing evidence for decisions that are being made. That's what we're presenting. And so I'll show how this can be done using state-of-the-art models for a workflow that combines structured and unstructured data for knowledge graph construction for use in GraphRAG. And the reason for this, I mean, I think there's some really good papers. This is some research that came out of Bosch recently this summer. LLMs are fantastic. They do really great work. They're syntax engines, and there's fantastic use cases for Gen AI, but there are also cases where LLMs just really don't fit the bill. And I think that the Bosch team has explored this a lot with what, really were some boundaries of what can or can't be done. Similarly, excellent paper by Gail Veracquo out of Scikit-learn and others, Sasha Lucioni from Hugging Face, Meredith Whitaker from Signal, and they have an excellent paper that shows, even though there are scaling laws for large models, there's also diminishing returns, particularly when you look at specific use cases. We definitely see this in NLP where, like for instance, state-of-the-art models for named entity recognition, really, bidirectional transformers work better than LLMs currently. So that's a caveat that maybe you don't just want to automatically build a graph with an LLM, you want to break it up. Okay, and let me give some background about entity resolution. Okay. So I'm from a company called Sensing. The core team, they've been working on this. They've been working together for like 20, 25 years or more. And it's largely in public sector, but this comes out of work. Originally, they were doing work around Las Vegas casinos. If you've ever seen the movie 21 with Kevin Spacey, the MIT math students who went to do card counting in Vegas and got busted. Actually, this team that I'm on, they were involved with getting those students busted. And we do a lot of work in, voter registration, passport control. Our customers use it for these kind of cases. Like I say, voter registration, passport control, counterterrorism, cyber threat, money laundering, sanctions compliance, even illegal fishing, catching that. So it's a really, really interesting area, but it's very much something where you have to show the evidence. And so as far as what entity resolution is, frankly, it's not just a matter of like doing string matching to say that two nodes are representing the same entity. It's a lot more complex than that. And like I say, typically we're working on investigations. Usually there's some kind of iterative nature, and we have to be able to show why decisions were made, why were records decided that they should be merged or unmerged because of the evidence. And so the gist of this is that you want to work with structured data, typically 2 or more sources of structured data. You want to be working with 2 or more features across the data sets, typically PII kind of features like names, addresses, tax ID, transponder code, affiliations, etc. And if all of your data was just in one language, say it was all in English, it was all cleaned up, it followed standard formats, then yeah, you could look at like string edit distances and make some really easy decisions about how to do merges. But in the real world, it's really different. And you might have a data set that's in Arabic, and then you have another data set where the names have been transliterated from Arabic into Italian. And there might be 5 ways to transliterate a name from Arabic to Italian. You might have other data sets that have names of companies that some of them are in Mandarin or Cyrillic or Korean. Some of them have the English representations. Trying to work across the different cultural conventions and scripts in different languages, it's really difficult. And the thing is that it's the edge cases that are important, because if you are powering up a team that, I don't know, they're tracking whether or not somebody is bringing dirty bombs into a metro area, they're concerned about the edge cases. They're not concerned about the easy nodes to match, right? They want to catch all the edge cases. Similarly with like voter registration, you really can't afford to take a machine learning approach and think of like false negatives and false positives. You have to handle all the edge cases. And so having decades of understanding what those edge cases are and how to handle them across different cultures and languages is really crucial. And here's an example of a kind of tradecraft for bad actors would be like channel separation, where somebody is a known actor, they're a known money launderer. They will create accounts. They might change their name or their address, but then they will try to move through these different channels and play them off each other to gain reputation. But by doing entity resolution, you're able to draw those links to understand that there are consistent entities across the different data sets. And we have something that we call entity-centric learning. You can think of it as like using all these different features and triangulating on the data sets. So, you might have a name that's represented in multiple ways, but it's the same person. You might have an address that's represented in multiple ways. It's the same one. And like I said, it gets really difficult if you're working across different scripts, different cultural conventions. You really have to understand the cultural norms to be able to do this kind of work. And certainly it's not string matching in this case. So, here is someone, Abdullah Qadash, and his name transliterated into English. There might be several ways. In this case, he made a pilgrimage to Mecca, so he has Al-Hajj in front of his name. That's a formal thing. Or, his dad was famous. He has been son of Amir. We're able to pick that up by doing entity-centric learning and give it a high score and match these 2 addresses at top. Conversely, though, you take a look at, like, in English, John R. Smith versus John E. Smith. Those should be different people. But if you're using string edit distance to compare nodes, those are only one letter off. And so we're able to distinguish cases like that. But the bottom line is that culture dictates how you have to do the comparisons. And similarly, if you've ever been to Singapore, one of my favorite cities, you know that addresses in Singapore can be really complex because you've got this confluence of multiple different cultures. And so at the top, here is an address, very, very different. It's actually the same address. We can catch that. But then at the bottom, you see Orchard Tower Plaza. There's a great shopping center there. And one letter off is actually two very different businesses. So there's a lot of non-obvious relationships. You have to be very careful how you do this kind of entity resolution. And I'm going to scoot forward just to say there's an ensemble of different approaches that are being used inside of our API. And various different rule-based or models to do the different parts. But to use it, it's simply JSON in and JSON out. Calling the API is pretty simple. And now that brings us to the graph parts. I love this quote: think of data as an imperfect map of underlying entities. So if you have a number of data sets, you can think of them as an imperfect map of nodes, relations, and properties underneath. And it's our job to figure out what those nodes, relations, and properties are. And so we talk about ERKG, entity resolved knowledge graphs, using entity resolution to really build out a kind of backbone that is accountable, that is explainable for how you're doing the merge to build up your graph. And so when we take the output, we will be pointing out to the data records. We preserve the original data records. Those are evidence. But we build on top of it a kind of overlay. And you can think of this overlay, its entities, its relations, its properties. It's a kind of backbone for organizing the graph. I'm going to skip through a little bit just in the interest of time. Here's an example from Panama Papers. Here's an individual, Avasam Shah, and he's involved in some different companies. If you just take the data as it is and try to link it together, this is what comes out of the data. But if you run entity resolution across it, then you can start to see that there is this individual, Badshah, who's involved with a couple of offshore corporations, Barlow's and Walhansia. And now you can start to do more work with a graph, for instance, running graph analytics like centrality measures to see who are really the central players here. Okay. So let me present a kind of generalized architecture for this type of work. Let's say that we've got structured data and unstructured data sources. And, we're going to be building up assets into graph database and a vector store. On the top, we take our structured data sources, we move the data records into the graph database, but we also peel off the features for PII, run those through entity resolution, and that kind of overlay, that kind of backbone goes into organizing the graph. We also use entity resolution to build up a customized domain-specific entity linker. Okay. And then down at the bottom, take your unstructured data sources. In RAG, typically you will chunk the documents, run them through an embedding model, drop them into your vector store, but also take and parse those text chunks and run NER, run relation extraction on them, build up a lexical graph, and then use the results of entity resolution to do really smart entity linking in a domain. And so now when you've got different elements that are in your graph or in your vector store, they're tied together in many ways. When you go to use those downstream, if a prompt comes in, you can run the prompt through your embedding model, do vector similarity, vector database, et cetera. Or also go off and generate queries, run through your graph database, and then take some other steps, run a semantic random walk or run some type of graph analytics to really understand the interactions across multiple hops inside the graph side of what's going on before it gets presented to the LLM. So here's just talking about these steps one by one. We can use state-of-the-art models at each point, but I should definitely say after you've run through and you understand your domain, you've got some results, you might want to step back and get human feedback and then iterate, do some fine-tuning for the models at each of the major steps. So to show this, let's work with Spacy. For instance, if you do a Spacy parse of a sentence, the noun phrases can be identified as potentially entities. There's named entity recognition is a way of doing this. The current state-of-the-art model, there's a zero-shot approach called GLEIF, which is really excellent. And then there's one that would require some fine tuning, perhaps after GLEIF, called span marker. This is about inferring nodes. There's a really great tutorial, illustrated GLEIF, and then also another hands-on tutorial where you take and run GLEIF first, get the results, do some feedback, some human in the loop on it, and then use that to fine-tune, run training on span marker. So you can really get state-of-the-art for your domain. Relation extraction is a different area. There's GLEIREL, there's MREBEL. There's an older project called OpenNRE. This area hasn't seen enough work really, and frankly, a lot of these models, the tokenization used in these models is kind of wacky. So I think that this is an area of inferring edges. We'll see a lot more work in it. But what I do want to mention, something very new, Louis Guiton took, again, with ICIJ Panama Papers, using the results of entity resolution to customize an entity linker. And now this is a spacey pipeline component, so you can use this, it's open source. And also, once you've got all these components built out of your unstructured data, there's an algorithm family called text graphs where you can start to link together components to build out your lexical graph. And then once you've done that, you can do things like semantic random walks to enrich your graph, particularly if you have WordNet or Thesaurus or results of entity resolution. There's also the testing aspect. There are ways like Shackle, if you do have strict semantic definitions like RDF and OWL, you can use shape constraint rules. But more generally, you can use probabilistic soft logic to define rules and understand where outliers are. Every time you update the graph, you can sort of measure consistently and identify outliers. So this is a way of testing nodes and edges. And overall, what we're trying to do here is to iterate toward very general definitions to more specific, uncertainty toward confident decisions, trying to get better elements to build our graphs. Okay, so some demos real quick. There's a series of demos about entity resolved knowledge graphs, and this focuses on using some data in the Las Vegas metro area, businesses in Las Vegas. During the pandemic, there were the PPP loans that the government made. There was a lot of fraud, and so this is using graphs to be able to identify some of the PPP loan fraud. And the idea is the data records go in the graph store in Neo4j, and then the PII features are peeled off, run through sensing. This creates a kind of overlay to organize the graph. And so you go from a lot of unconnected to interesting patterns, and this can be used for visualization, interactive drill down, graph analytics like with GDS, doing GraphRAG, et cetera. I did this tutorial. I got to work with ABK and other folks at Neo4j. It was really, really fun showing how to do PPP fraud analysis using Neo4j. And then Claire Sullivan, my colleague, also no stranger around Neo4j, she took this and enhanced it with using LangChain to do GraphRAG, creating a chatbot where you could explore the fraud in this area. There's a number of articles from other partner firms that are doing work with entity resolution and knowledge graphs, a lot of great case studies there. And then also on the unstructured side, here's a GitHub repo and a video about the workflow that I described. And for Louis Guiton, the entity linking based on entity resolution, here's a tutorial for it. And in fact, here using Spacey, you can see that when the entities are extracted from the text, they're automatically linked to the identifiers in the knowledge graph. And just in general, all of this is talking about a kind of hybrid merger happening between symbolic AI, knowledge graphs, and more of the statistical side, machine learning. There's a great talk about this by Frank von Harmelin that I'll definitely reference. And just to finish up, if you want to get involved in this area, Open Sanctions has a project called Follow the Money. There's a schema being developed for a lot of this. They need help, graph people especially. There's the BODS standards for beneficial ownership compliance around the world. There are the organizations that receive leaks and work with the data, ICIJ and OCCPR. They need people as well. And Graph Geeks, I'll give a shout out. We've got a study group about investigative graphs, and there's some great community resources. I'll give a shout out here to a few of them: GraphRAG Discord, ERKG discussion group on LinkedIn. And I also do a webinar in this area every month or so. And if you want to get a hold of me, let's link up on LinkedIn. With that, let me cut back over to stop sharing and see if I can start answering any questions.